For this next one where we have y equals cosine of 3x, it actually affects the graph in a way that's not going to relate well to anything you've done in the past. What it's going to do is affect the scrunchiness of it. That's not the technical term, but I'm going to show you what I mean. Here's a beautiful graph of y equals cosine of x, and I'm going to just really briefly type in one of those great sliders that I can do and add a slider. And you're going to notice that as I let a, like say for example, equal 3, whoa, that blue graph, the period's going to change. It's going to change how often it does stuff. If I go this way with it, the period changes. And the question becomes, how do we figure out exactly how that period changes based on the value that's multiplying x? And I purposely picked one that's actually really hard to work with, or about as hard as it could be maybe, because I didn't want to do the easy example in the notes and then have you guys come across a hard one. But the basic idea is going to be this. We're going to figure out, based off the fact that we know that this function, let's get this out of here, that this green function's period begins, it's like a 2 pi interval. That it begins, what it's doing at 0, it starts to repeat at 2 pi. We're going to use that idea to help us figure out how the period changes when it's a 3x instead of just a plain old x. So we're definitely going to rely on the fact that the standard function, whatever it's doing at 0, once it hits 2 pi, it starts to repeat that. Let's figure out how those values change when we have a multiplier in front of x. You're going to see me doing a lot of work with fractions here because it makes my job easier. And you're going to see me, I forgot what the same thing I was going to say was, but you're going to see me do something else, and let's just do it. It's going to be great. So the idea is we have y equals cosine of 3x, and we want to pinpoint how that beginning and end point are going to change. We know that typically happens at 0 and 2 pi, so I'll start by saying, when does that equal 0? And that's not going to shock anybody. And when does that equal 2 pi? So whatever's stuck inside that cosine function, I'm going to set that equal to 0 and set it equal to 2 pi, knowing that the graph will do one full cycle within those x values. And solving both these equations, if I solve this one, x is going to equal 0. If I solve this one, x is going to equal 2 pi over 3. So my graph, ga-ding, ga-ding, is going to start to repeat after 2 pi over 3. So I'll put a 0. I'm not going to draw this to scale, so these graphs are not going to look much different. Now here's where my fun with fractions comes in. This is one full period. Cosine's got to start to repeat one time right after this interval. I want to cut this interval in half, and then I want to cut those halves in half to get the quartiles. I'm going to do some math down here to help me with that, because what I'm going to use, actually, the first interval for this one's not too bad. If you want to cut this in half, you're basically taking this 2 pi over 3, right? Bear with me. You're going to be like, Mr. Depthick, I can do that in my head. I'm going to show you why we're going to do it the long way. And instead of dividing by 2, I can multiply that by a half, of course. And you might be thinking, hey, why don't you cancel those fractions? I'm not even going to do that. Half of 2 pi over 3, I'm going to write down as 2 pi over 6. And I'm not going to reduce that fraction. Not going to do it. I'm not going to do it. And then I'm going to find the halfway point of these points. So I take that 2 pi over 6, and instead of dividing it by 2, I can multiply it by a half. And that's going to give me 2 pi over 12. So halfway between these 2 points is 2 pi over 12. To avoid doing annoying math when trying to figure out this halfway point, I want to point something out. And that is that if I write all of these with the same denominator, this becomes pretty easy to find. So let me erase a couple things here. Ga-ding, ga-ding. Let me pause. Okay, so what I've done over here on the left side is I've rewritten these same values. I had the 0, I had the 2 pi over 3 from these two solutions. I could find the halfway point by basically just doubling that guy's denominator. I could find the halfway point again by doubling the denominator or multiplying by a half. And then I'm going to look at these as if they all had the same denominator. So the common denominator between these three fractions is 12. So 2 pi over 12 will stay. If I write this as over 12, I'll multiply top and bottom by 2. So 2 pi over 6 is 4 pi over 12. And then if I multiply this guy's top and bottom by 4, I'll get another 12. So 2 pi times, I'll get 8 pi over 12. Right? And then it's pretty obvious to see the pattern. I think we're going from 0 to 2 pi over 12, to 4 pi over 12, to something over 12, to 8 pi over 12. So what would complete this pattern? From 0 to 2 to 4 to 6 pi. And the other thing that you might notice that I'm doing is this looks overwhelming. Everyone who sees this the first time tends to get horrified by it, right? We got fractions in there, we got pi's in there. I'm really having to train my brain to once you get common denominators, you don't need to worry about the denominators anymore. You can put them out of your head. And the pi's, we just are going to carry those around as well. So even though this looks pretty hideous, and if I were to say to you, what's the missing number in this pattern here? It might be like, oh my gosh, I don't know. If I ignore the fact that there's 12s here, and if I ignore the pi's, you can see it's going 2, 4, something, 8. So 6, and then it's pi, and then it's 12. So that's the number that'll be over here, 6 pi over 12. Now, of course, I'm going to reduce these fractions when I put the grids up here. So I'm not going to write 2 pi over 12. I'm going to say this is, well, let's go to the halfway mark. The halfway mark is pi over 3. Half of that halfway mark is pi over 6. And half of this halfway mark is this guy reduced is pi over 2. These are my new points of interest. And of course they'll be on the other side as well. So I'll have a negative pi over 6, a negative pi over 3, so on and so forth. Once I have these x values nailed down, the only thing left to figure out is we're doing cosine. So where do I start? Cosine goes up 1, so I'll go up here to 1. This is 0. This is a negative 1. This is back to 0. This is back up to 1. And then this goes down to 0, down to negative 1, up here, boom. So I did a lot of arithmetic and stuff that you guys learned in elementary school but haven't practiced since, and it doesn't look like elementary school math at all because it's got pi's and fractions and stuff. But if I was just going to recap this 8-minute video, holy mackerel, we got to figure out what makes this equal 0, what makes it equal 2 pi, get those values. Once I have those values, find the halfway point, find the half of the halfway point, and work it from there. Good luck with this, you guys. It's going to be fun.